Welcome to clickmyproject.com.
Yeah, let us discuss about the automatic brain tumor tissue detection based on hierarchical centroid shape descriptor in T1 weighted MR images. Yeah, let us discuss about the abstract of the product. So, the magnetic resonance imaging is a standard modality used in medicine for brain diagnosis and treatment. So, it offers the advanced tubia in non-invasive technique that enables the analysis for brain tissues. The early detection of tumor in the brain leads on saving the patient life through the proper care. So, due to the increasing of medical data flow, the accurate detection of tumors in the MRI slices becomes a fast user's task of a performance. So, to furthermore, the tumor detection in an image is useful not only the medical accepts but also for the other purposes like segmentation and 3D image reconstruction. So, in the proposed work, the segmentation in medical images were more helpful for the identification of the disease portions in the images. So, in the pre-processing steps is the first the process of segmentation process. So the images were filtered using the median filter, which smoothens the overall images and makes the intensity all over the images normalized. So the clustering process is employed for the images based on the K-means process. By using the clustering concept, we're using the K-means. So here the K-means is based on the remove the skull region, and then it's used to easily segment the part of the brain tumor tissue. So the thresholding is the process of employed for the segmentation of the tumorous portion in the input images. And then the next step is a level segmentation process, which is employed for the segmentation of tumorous portions in the input images of the process. So finally, the performance analysis of this measure based on the performance metrics like true positive, false positive, and true negative and false negative, and also calculating the accurate precision recall of the process. So this is the abstract of the process. Yeah, let us discuss about the flow diagram of the process. So this is the overall flow diagram. In this flow diagram, is first of all we take an input image. So input image we get the MRI data set, and then pre-processing step. In the pre-processing step, we are using the median filter, and then segmentation. In the segmentation step, we are using the two type of segmentation. One is the K-means clustering, another one is the thresholding concept, and then performance measure. So in the performance measure, we are using the true positive and negative, false positive and negative, and accuracy in the precision and recall. Then we will describe about the recall, and then we describe detailing about the median filter. So the median filter is employed to smoothen the image and to filter unwanted pixel in the image. So median filter passes through the image pixel by pixel, replacing each pixel with the median neighboring pixels, thereby providing normalized intensity in the overall images. So the noise in the images were replaced by above the process. So and then skull region capture along to the brain region in the images were different intensity and in large area. So the skull region when identify and remove the morphological operation. So the morphological operation is where remove the close operation. The structuring element is a small binary. So that is a small matrix of pixels, each with a value of a 0, and closing of an image structuring element is a dilation followed by the erosion. So the opening of an image by structuring element is an erosion followed by the dilation. So and then the clustering concept. So here the we using the clustering concept is a K-means clustering. The regions in the images then have having similar intensity in the cluster using the K-means algorithm. In fuzzy clustering, every point has a degree of belonging to clusters, as in the fuzzy logic, rather than belonging completely to the just one cluster. So just points of the edge of cluster may be in the cluster to the lesser degree than the points. An overview and comparison of different fuzzy clustering algorithm is available. So any point of the images can set the coefficient, and then the kth is to be each calculator. So each cluster region represents regions of different intensity, and also calculating the process of the calculation, and then performance measure. Finally, we calculating the performance measure by using the formulas. So the performance measure can be calculated this by using the like that segmentation of the process. So the performance of the process is measured by measuring the accuracy of the process, and the accuracy is measured by comparing with ground truth of the images. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the process. So click the main guide and then run. So it's take us some time to open the guide design. So this is the main guide design. So in this main guide design, the process is automatic brain tumor tissue detection based on hierarchical centroid shape descriptor in T1 weighted MR images. So first of all, click the button input images. So these are the databases. So different type of databases are presented. I will select the fifth image. So and then click open. So the input image should be displayed, and then pre-processing step. So in the pre-processing step, there are two types. One is a noise removal, another one is a brain extraction. So that should be enabled. So on the noise removal, applying a median filter, the pre-processed image it should be displayed. And then brain extraction. So in the brain extraction, the skull remote region it should be displayed. So this is the noise removal and brain extraction of the process. And then the next process is the segmentation. So in the segmentation images, click the button segmentation. There are two types. One is a k-mean clustering, another one is a HCSD. So HCSD is a hierarchical centroid shape vector T1 weighted MRI images. So click the k-mean clustering. It will display four type of clusters: clustering 1, clustering 2, clustering 3, clustering 4, based on the base paper of the process. So next figure is display. So in this image, that is an image labeled by cluster index. So this is a clustering type by using the k-means clustering. And then HCSD. So that is a hierarchical centroid shape descriptor. So click this. So the hierarchical centroid descriptor displaying the counter growing of the process. So this is the process of HCSD. And then the next guide design will be open. So in the next guide design, it will display. So this is the next guide design. So in this next guide design, the process will be displayed in the feature extraction, classification, and the performance estimation. So in the feature extraction process, we extract the features by using the GLCM. So this is the feature extraction. So these are the feature extraction values. So these all the values are feature extraction process. And then classification. So in the classification process, which patient, I mean the person or a person, tumor will be detected. So to identify the person name or a person number like that. So click the classification process. So it will be recognize the tumor image in the fifth image. So it is that like I will select the input image is 5. So it should be classified. The recognized tumor image should be 5. And then finally calculating the performance estimation. The performance estimation value calculated: true positive, true negative, false positive, false negative, accuracy, precision, recall. So these all the values are calculated by using the formula. So finally here we display number of total pixels in the images. So white pixels, black pixels, and the ratio and then area. So area means it will be detected by the tumor area. So these are the overall running procedure for the process.
Thank you for listening this video.